Hello guys, welcome back to my channel again, which is Sugilanon channel, the unveiling story and sparking joy. Well, in this video, we will be talking about and try to learn about atoms, molecules, and ion. If you could still recall with our previous lesson, so we have been discussing those scientists, famous scientists who have been contributed to the atomic structure. And in this video, we will be discussing what is inside the atom or the subatomic particle. By the way, the title of our topic for today is all about atoms, molecules, and ions. This is me again. I am your chemistry teacher, your presenter, Rafael Padla Inson. Well, set back and get ready. In the first place, the atoms, molecule, and ions I have prepared for you, we have been limited to this topic outline, which is what is atoms, elements, compounds, molecules, and ions. So we'll try to find out that exactly when it comes to their meanings. And of course, we're trying to learn what are those protons, electrons, neutrons, mass number, ions, and isotopes. I know that you have been heard about this term, but in this video, we will give emphasis and really give you learning if you try to be focused with your attention. Okay, so let's have first with the term atom. In the previous video, we all know that atom really started from Lysippus Democritus until what we have now, which is the modern chemistry, modern world, which is really, we had been benefited out of it. So to give a review to you, what is atom? We all know that atom is the basic building block of all matter. So meaning to say, from the state of matter, solid, liquid, and gas, inside in it, there are always an atoms, okay? And of course, according to the other scientists, that elements just or the substance that consists only of one type of atom is what we called element. So among the 118 elements reflected in the periodic table, there are atoms inside in it. And of course, according to the theory, John Dalton, that atoms of one element is different from the atoms of all other elements. The reason why atoms can able to be combined, react, rearrange, and etc. And that is really an element. Okay, so consists only of one type of atoms, and all atoms in that given elements are identical in size, shape, and mass. Okay, and of course, for the compound, when we say compound, that is a substance formed when two or more different elements are chemically bonded together. So it's either in the form of covalent band, ionic band, metallic band, or whatever it is, as long as there are two or more different. Actually, specifically, when we say compound, that should be two different elements, no, combined together. But more than that, more than two is what we call the molecules. But try to understand that when atoms join together, it would really form a compound or a substance. For a continuation, for the molecules, that is a group of two or more atoms held together by a chemical bonds. No, actually, there are a lot of molecules in the world, biomolecules that human have. The four macro biomolecules, no? We have carbohydrates, proteins, lipids, and nucleic acids, etc. So there are a lot of molecules in the world, but as long as we combine elements to the other elements with two or more, that is a molecule. And of course, when we say ion, that is a substance that has a positive or negative charge. Anything that an atom does bears a positive charge in their superscript or negative, that's categorically termed as ion. Okay, so we'll try to find out what is ion later on. For a short recall, when we say atom, of course, this is the new model of atom according to Erwin Schrödinger, that when we say atom, there should be a, what do you call this one? Nucleus. So nucleus, according to Ernest Rutherford, if you could still remember, that is located at the center of an atom. So that's a very small, heavy part of the atom in the middle, and that is the nucleus. And we have the electron cloud. So we need to say, according to Ernst Schrödinger, that electron cloud is the probability of finding electrons in a particular atom. So that's the certain region where the electrons are keeps on moving, because we all know that electrons are definitely constantly moving, no, because they're both negative charge. They always collide with each other to create an electron cloud. And of course, when you say electron clouds, that's a lightweight part of the atom. Okay. And actually, the nucleus inside in it, the subatomic particle, is where the protons is being located. So when you say proton, that's have a positive charge, which is residing in the nucleus, and all atoms are distinguished by the number of protons it has. Say for, it has, say, or their atomic number. The atomic number, as we are trying to discuss later, corresponds also to the number of atom. But the what most important here is protons is located in the nucleus. And of course, the neutron. So that's not only a proton isolated there, but proton and neutrons are also located in the nucleus. Actually, eventually, when we say neutrons, it doesn't have no charge at all and have the same mass as protons, but of course, that's slightly heavier than that of proton when it comes to their masses. Okay, and say for example, the electron clouds. That electron clouds contain, of course, as we have seen, that's an electron. Okay, where the pathway where the electrons are keeps on moving. Okay, it's not really that a certain orbit, but where the region in where we can find electron, yes, that's an electron cloud, and have a negative charge and are contained within the shell of the electron cloud. Okay, and of course orbit the nucleus of the region according to Niels Bohr. But specifically, it's not really a certain orbit, but within that area or orbit. So electrons have a very small mass compound compared to protons and neutron. It's slightly less than amount or mass when compared to the two, and determine bonding properties of the substance. So what makes it really a certain element or atom combine or react with the other or the rest? Yes, true to not their electrons or their valence electrons. So this is the structure of an atom, where the nucleon represented as a color orange, yellow for the proton, and of course electrons for the green. So that's there are only three subatomic particles: the protons, neutrons, which is located in the nucleus, and the electrons were in outside of that nucleus. Let's make it an element, because when we say elements that contain one or more the same type of atoms. So again, every element we have in the periodic table has their own kind of atom, and depending on their number of atoms or atomic number, that corresponds to their, what do you call, their identical when it comes to their sizes and shape. So no matter how many or small the elements or atoms inside the elements, they are identical with each other. So examples of elements are hydrogen, one proton, carbon, six proton. Because where did we what we consider, why we could tell it that carbon has six proton? Because the atomic number of carbon is six. Again, the atomic number designate as well with their number of protons in neutral atom. Since the atomic number of oxygen is 8, so the number of protons of oxygen is also 8. With copper, the atomic number of copper is 29, so the atomic or the proton of copper is also 29. And the gold is 79, which is also 79. These are the few examples of the protons and their atomic number. From hydrogen, helium, lithium, carbon, nitrogen, and oxygen. So their atomic number is 1, 2, 3, 4, 5, 6, 7, and 8. So that's also their number of atoms. And for the compounds, this is a compound that contains more than one type of atom. So example of organic compounds, a compound with carbon atoms joined together. And just like with this one, carbon dioxide, when an atom of carbon and an atom of oxygen join together, so the one carbon atom and the two atoms of oxygen form in a whole number ratio with their proportional ratio. For example, the inorganic compound, a compound with no carbon atom, yes, that's an inorganic compound. Or in the field of inorganic chemistry, that's part of where when we say in inorganic chemistry, the study of all elements presented in the periodic table except for carbon. Where when we say organic chemistry is the study of all carbon-containing compound, other with the exceptions of other elements, non-metal. Yes, that's their category. So water atoms of there are two atoms of hydrogen and one atom of oxygen. So that's an example of a compound. When it comes to the molecules, that's a group of two or more atoms held together by a chemical bonds. Hold together, the past tense is held together by the chemical bonds. So two or more, that's it's already a large number of elements joining together. So that's make it a molecule as a whole. And of course, the example of molecules is just like this. So this are three-dimensional features of a molecules of carbon, where the center is the carbon and the four terminal hydrogen atoms. That's my own prediction. And of course, the complex ones, the benzene ring, no? How many carbon and atom connected to a certain carbon to make it as non-polarity of a molecule. And the color pink is the complex. Now it's a large number of molecules. So the weight of the molecules depend on its chemical composition of how many it is. No, it's for analogy, the number of atom presented as many as we can, then the heavier the atom it is. Really, compared to the less number of atom. And for biological molecules, that's what makes our body, like DNA and other chemical structure, made of. That's a molecule. And say, for example, for the molecules, so we have when a molecule is an aggregate of two or more atoms in the definite arrangement held together by a chemical bond. So when two elements of hydrogen join together to form a molecule, so that's an elemental molecule, okay? But when we have two or more different elements joined together, that makes it a molecule as a molecular compound, especially when, for example, two molecules of hydrogen, one mole of molecule of oxygen to make it as a water, and for the ammonia and carbon. Be remembered always that the diatomic molecule consists only of two atoms. So meaning to say, diagonally from the prefix is di means two, mono means one, tri means three. So yes, the atomic molecule is a combination of two molecules. And of course, two molecules or two elemental molecules. And the polyatomic molecules, of course, the poly means many, so it should be two or more. Shall we say, when we say poly, that's considerably three or more, because we have a diatomic molecules for this combination of exactly two different elements. But anyway, when we say poly, the two types of molecules is the atomic molecules and of course the polyatomic molecules. As you can see in the example, for the we have more than two atoms, the ozone, O3, H2O2, ammonia, and CH4. So when these different elements join together, then that makes it as a chemical composition of a molecule. And we have now in the ions. Ions. What are ions? So an ion is an atom or group of atoms with possible possibility of negative or positive charge at all. So when an atom is neutral, it is neither a positive or negative charge. So when we say neutral, it doesn't have charge at all that you can see in a certain element. Neutral nga eh. So because if they have charges with each other, it would only cancel out and return it to its neutrality. Okay, that's a neutral atom. In each order of the atom to be neutral, the number of electrons must equal the number of protons. The positive and negative charge cancel each other. So in that situation, mild situation, yes, we can have that certain kind of that. Um, when we say yes, we have now electrons, equal number of protons, then the positive, negative charge cancel each other. So if an atom does not have the same number of protons and electrons, then an ion is formed. So shall we say that we have more than protons compared to the number of electrons? It should be, maybe call it as a polyatomic. So take note that for the monatomic an ion, if we have more than electrons compared to the number of protons, so that's your mnemonic criteria. If an atom does have the same number of protons and electron, an ion is formed. Does not, rather. Remember, if an atom does not have the same number of proton and that of electrons, then you could probably say that I am very okay and happy. So as I said, when atom does not have the same number of protons and electrons, then that is an ion. When an atom loses or gain one or more electrons, it acquires net electrical and that it is in. Okay, so that's how we could consider atom elements, molecules, compounds, and ions. And probably when we say ions, ions are both a group of atoms with possibility of negative charge. Well, there are two types of ions, the cations and of course the anion. Remember in the colored red, sodium cations with one positively charged. So those ions that has bare positively charged is what we call it as a cation. But any form of negatively charged is called for that. We can call for that as an ion for the negatively charged. So when an ion is negative charge, yes, it does become like that. But the simple illustration is when electron is being lost, when we lose or one electron is given off, taken away from its atom, then the number of electrons and protons are no longer balanced. So the remaining is when we get away electron, then there should be an excess depending on how many electrons has been removed. So for example, we remove two electrons in a certain atom. So meaning to say, if you try to compare the protons and electrons, there are more excess of protons because electron has been removed. So I think there are two, as depending on how many we have been removing in a certain situation. And electrons and ions with a negatively charged, that's the color green, and it becomes an ion. So how do we call those negatively charged? An ions, and the positively charged is the cation. Take a look that an ions has a negatively charged because they receive an electron. So mean to say it they have an excess number of electrons. That's why they have a negatively charged compared to the positively charged, which should be how many electrons you have in order for you to fight. Okay, that's the consideration in there. And the next one is let's try to give emphasis back to the atom because we are always mentioning the atom. So for the mastery level, when we say atom, that's a basic unit of matter that consists of dense, much more heavy, controlled nucleus surrounded by an atom of negatively charged electrons. And that's what we call it as an atom. For the model of an atom as a review, so we have as previously presented, so we have the color blue are the representation of an electrons and the yellow and red is for the nucleus or protons and neutrons. Congratulations. The protons, where can we say that the particular situation is the proton? So remember with this principle, each element in the periodic table has an atomic number, which tells how many protons and of elect atom, how many protons in an atoms of the element has. So actually, when we say elements or atomic number, which tells the number of protons. So as I repeat, that the atomic number signifies the number of protons as well. So each element also has a mass number. You could find the mass number of a certain element in the periodic table or below with your activity notebook from the previous. And of course, mm, the element also has a mass number. So we have to try to familiarize and memorize this conventional formula. Mass number is equal to the number of protons and electrons. So that's how we try to calculate the mass number if we have given the number of electrons. Okay, so please be reminded with that one. Again, mass number is equal to number of proton plus number of neutron in order to solve for the mass number. This is just a representation of an element of carbon where originally the mass number is a large number, no, compared to an oxygen. So that's how we would work out that one. And there are other symbols for that number of proton, which is also can be considered as atomic number of an element. So let me say atomic number of an element is the number of protons in the nucleus for each atom of that excitement of that certain element. So again, the atomic number and the number of protons, which the atomic number symbolized with the letter Z, that's automatically that we are referring to the atomic number. And of course, atomic number of the nucleus, just let's try to compare with this one. An element of carbon, phosphorus, and gold, the number of their protons is many also. So for example, if we know the number of protons of carbon, where can we project that one? Please just only open your periodic table for you to identify if you have not yet memorized all the elements in the periodic table. So therefore, the number of elements in the periodic tables is equal to the number of protons and of course the number of electrons. So for the number of not electrons, later I will tell you that. So when you say carbon, the number of proton is also the atomic number. You are always experiencing drinking every day. And for the phosphorus, the atomic number, why is 15 is the number of proton? Yes, I heard you, because 15, because the atomic number of phosphorus is 15. Okay, so the Z is the atomic number. And for the gold, we have the number of proton is 79 because the atomic number of gold is 79. That's a proton. Let's go for the electron. We have to know what is the really the function of electron. In neutral atom have the same number of electrons, negative charge, as they do protons, the positively charged. So please do not forget the word neutral atom. Okay. So for the neutral atom, that is a kind of atom that don't have a charges. So the neutral atoms have the same number of electrons, negative charge, and they do on protons, positively charged. So the formula for getting the electron is number of electron is equal to the number of proton, of course, or the atomic number. So we'll try to find out how many electrons we have in the periodic table or in every element. So take note that in every element, if that certain element is located to a specific atomic number, then that certain specific number is equivalent to the number of elements. So for example, I got one, so na siya? I got a calcium of the atomic number is 20, and then the proton is 20, and the electron is also 20, because yes, in the statement, number of electrons is equal to the atomic number. Only in in neutral atom, remember with that one. Please, quote unquote, in neutral atom. When can we say that a certain atom is neutral? Well, if they don't have charges at all carrying at their back. So meaning to say, the number of electrons and proton is equal in a neutral atom, but it will not have the same story when our molecules or species are yes, charge or ions. Okay. Next one, let's practice. Find the hydrogen, helium, lithium, carbon, nitrogen, oxygen in the periodic table. So it's easy to remember if you, as long as you have your periodic table. And how many proton does of hydrogen, helium, lithium, carbon, nitrogen, and oxygen? So as I said, it's depending on how you will solve this problem. So since the hydrogen is located to the atomic number one, we don't any need to argue. The number of protons of hydrogen is one. How many protons of helium is this? So the atomic number of helium is two. So the number of protons is also two. And carbon is six. The atomic number is six. So the number of protons is also six. Okay, so how many neutrons? Well, in identifying the neutron, just try to open in your periodic table. You have to familiarize there that the number of neutron, the mass number is located in there, and also with the atomic number. Actually, we have a certain formula for getting that one. But in this case, the number of neutron, when are we trying to determine how we will know the number of neutron? Well, to determine the number of neutron, we just simply follow the procedure, or you have to so allow yourself of for example, the atomic number, the mass number of carbon is 12.01, so you're rounding it off to whole number ratio so that you have a many electrons. Okay, so this is an example of hydrogen. Atomic number is 1, so the number of electron is also 1. Nitrogen is 7, the atomic number is 7, so the number of electrons is also 7. The same with atomic number of proton, because that certain elements are neutral. It has different story when it will be no longer neutral. Next, let's do the practice. So how many protons does an atom of hydrogen have? It's your turn. I already mentioned that one. And we have in the table, yes, feel free to read this properly. So say for example, an element of hydrogen, the number of protons is 1, so the atomic number is also 1. So I don't have any loose with this sugal because I have already what I'm trying to talk. So the number of protons is equal to the mass, the atomic number. Okay, next, the neutron. So neutron, so let's practice. When are we trying to know the neutron? If you can still remember the formula to get the neutron. So say for example, mass number is equal to the number of proton. So when you try to derive the equation, transpose the other side for the number of protons. So what is left behind? It's only the mass number of particular situation. So say for example, um, the formula of getting the neutron is the mass number. The conventional formula is mass number is equal to number of proton plus neutron. No, if you can still recall that one. And in order to calculate the number of neutron, just simply follow the line, and of course subtract, derive, equate the proton to the other side, so that it would be mass number minus proton. So that's the number of neutron. Well, let's have an example about that later. How many neutrons? So take note that in identifying the neutron, you have two things to, or many things to consider, and one of the best consideration there is the decimal. So we are all know that the decimal place of a certain atom is very high because it's a chemistry. But of course, just simply know the basic. When can we find the neutrons in the periodic table? Just simply subtract the mass number in from the atomic number. So say for example, how many neutrons of hydrogen have? Since then, hydrogen has one atomic number, and then the mass number is also one. What do you call it? Number of neutron, mass number of hydrogen is 2 minus proton, which is 1, so that's why 1. Okay, that's how we're trying to get the number of neutrons. And next is how many electrons does in a periodic table. First, say for example, for the carbon, the atomic number is 6, so the number of electrons is also 6, because a certain carbon is neutral. When can we say that it's neutral? It cannot win through simple situation just like this. So the electron. And next is the mass number. Take note, please consider the formula for the mass number. The mass number is equal to the number of proton plus neutron. Vice versa. If you want to calculate the number of neutron, of course, just equate the proton to the other side, or you have to jump it off. So, for example, the nuclide means the element, the nuclide oxygen, the number of neutrons is already 8. So, automatic, if you know how to read the periodic table, you would identify that the proton number of proton is also 8. And of course, from the concept of the neutral atom, since oxygen is a neutral atom, so the number of proton is equal to the number of electron and the mass number. So just simply mass number, if you've seen the picture projected above, the mass number is equal to number of proton plus neutron. Take note, 16. So that's correct. Arsenic. So just plug the number of proton for arsenic is 33 and number of neutron is 42. Just simply add the two line. Okay. So what should be the answer? Okay. 75. So the arsenic has a 75 mass number. So fill in the blank. What is the number of neutrons? So transpose to the other side. Neutron, and the problem here is we have only a proton. And of course, what's the next? Phosphorus, 31. So interpreting the chemical symbol, if you have seen this one, if you know already what is the number of protons, the mass number, then you have to create a symbol to represent a situation calculation is that kind of formula. So again, I repeat, mass number is equal to P plus N. P is the proton, N is neutron, and that is the representation. The subscript is written in the number proton, and then the upper side, the superscript, should be written in the form of, excuse me, mass number in the superscript. Okay. Next one is the ions. So ions, when atoms or group of atoms with positive or negative charge, that is ions. So taking away electron from the ion atom gives a cations with a positively charge. That's correct. No, when you try to lose one electron from a certain element or atom, then it's not longer an atom or neutral atom. It's already or what do you call this one? Cation, by the way. So the ions that bears positively charged is cations, or the ions that bears a negatively charged is the anion. So to tell you frankly, to differentiate at the bottom of that slides, the sodium plus and sodium no charge at all, and calcium 2 plus and then no charge at all. Remember that when sodium doesn't have any charge at it, it is considered as neutral atom. Since in our case, that sodium has a positively charge, so therefore, the that would create a cation, no? And the next example for the calcium, so that's an example for the cation. So I'm giving you with this slide for just only a representation or example of the anion. So we are all familiar that atoms are a group of atoms with positive negative change. So allow electrons or group of atoms and ions with negative charge. And of course, to tell a different story, an atom and ion book to have there is a charge in the superscript example. Okay, so that's the issue. In this case, we have two types of ion, the cations and the anions. So the cations are all just most likely bugoy-bugoy. What I'm tempting. So next is the ion. So the continuation for the types of ion. So we have the monoatomic ion. So when we say monoatomic ion, we have only one type of element. So regardless of their charge, so for example, in A plus, so one element, the charge would 1. But in the case of calcium, calcium element na siya charge na 1. Ano, not only 1 because the player is injured. So again, ang monoatomic ion, ang timailhan lang ani is isa lang siya ka-element na na-charge. But when you say polyatomic ions, two or more different kind of element joined together, and that makes it as a polyatomic ion. Okay? So next for the polyatomic ion is the ions atom has small molecules, overall positive or negative. So the same principle if you have to try to read that one. So actually, when it comes to the ions, the number of protons the number of protons in a species does not change. Only the electrons will change. So you might asking or wondering, sir, you haven't change the proton? Yes, of course, because the proton is located at the nucleus and it's very difficult, no, to get the proton away from inside the nucleus. So take note that the number of electron changes when number of proton doesn't change, but there are also other cases that would change. Okay, let's go back. So try to recall with this figure: positive charge, lose electron, negative charge, gain electron. So the nuclear symbol of atom. So the barium, for example, in here, we have a superscript of 2 plus. So meaning to say that the barium has a cation because it's 2 plus. And the subscript is 56, so that's the atomic number. And then the superscript is 157, that's the mass number. And in the other side, that an ion, the atomic number is 7, and then what the charge is, no, in the sulfur for the anion, the negative charge consider that it is an ion, then the 16 is the atomic number, then the 32 is the mass number. So try to look at with this example in the barium side. The number of proton is equal to the atomic number. So since the barium na atomic number nga 56, so how many proton in the barium? It's all have also 56. The number of neutrons, how to determine the number of neutrons? So number of neutron, mass number minus atomic number. So don't be absent because you might be given a, what do you call this one? A difficult situation. And of course, the number of electron. This is the most important. In neutral atom, the number of electron is equal to the number of proton plus the changes in temperature. So actually, there's kalabisan naman, no? Oh, in the formula, number of proton is 56 minus, that's conventional charge. Pila man charge sa barium 2. So 56 minus positive 2 so 54. On the other side, the sulfur minus 2 and then subscript 16 and then the mass number is 32. The number of proton is 16 and number of neutron of mga basa is also 16. The number of neutron is 16. So the determination of proton minus charge is, ang proton niya is 56 man, minus, why negative 2? Because negative 2 is the charge of the sulfur, which is negative. So algebraic expression, 56 minus or plus 2 is 18. No? 56 minus 2, 18. Sorry. 54 man siya. Oh, this is not a 56. Sorry. This is a 32 minus 16 because the charge minus charge sa proton is 16. 16 minus pila yung charge 2. So 18 ang answer, no? So that's not a 56. Don't go no. Next example, sodium atoms have how many protons? Do not guess. Try to look at in your periodic table and consider it. And before sa inyong classmate, all good. So, what is the number? Try to answer with this one, huh? This is your assignment for the ions. And of course, ions, for a self-review, how many protons, electrons are in aluminum ion, aluminum 3 plus. Do the algebraic calculation and expression. And this is another example. Ions are represented by the superscript charge and in the element symbol. So this is ion. If ang superscript is positive, that's cation, negative is an ion. So practice, how many protons and neutrons and electrons does can calcium have? So solve it. Okay. And this is your assignment problem. How many protons, neutrons, and electrons in a copper atom? It's very simple, please. And of course, number 2, how many, the atomic number of uranium is 62. How many number of electrons are there in the neutral atom? And next to that is, I know how many protons and how many electrons, protons in a certain particular, daghan na siya. So that's your assignment. mm, 50 items, 10 points each number or item. And this is for problems for both ions, etc., atoms and molecules, neutrons. Next is the last is the isotope. When we say isotopes, those are the atoms of the same element which contain the same number of protons but different number of neutrons. That's an isotope. The same atomic number but different mass number. That's the most important there, no? Same number of proton but different number of neutron. Or when you say different number of neutron because you subtract from the mass number, so that's it. It's still the same. So same P and different, and that's an isotope. Okay. Isotope, the representation of an element is, okay, for example, the atomic number Z symbolizes for the proton, and mass number is A, capital A, that's the mass number. So please remember that this particular term or device is not permanent, depending on how we will borrow. And of course, that's an isotope. What is the nuclide symbol X that represent for the element? A for the mass number and atomic number for below. Okay, so that's really an isotope. Example of isotope, we got isotope, the same atomic number but different mass number. So pareha silang hydrogen. Ay tulo ka kasi ng hydrogen. Ang isa, pareha silang atomic number no nga 111 but ilang mass number has different na ay mass number 1, na ay 2 and 3. So, but according to the principle nga naa daw manghilog ana nga nilog. Well, as I said, isotope is the same atomic number but different mass number. Another example for isotope is oxygen. So there are how many isotopic of oxygen? 8 na kay because natay oxygen 16, ay oxygen 17 and 18. So malamang that is what we call isotope. And of course, the isotope, another example is lithium. So they have the same number of lithium, but the mass number is different. The other one is 3, 3, 7, and 8. Okay? So isotope of sodium is another example. The most important there is you understood what is an isotope. That is a self-review. And of course, another uses and application for isotope. So it's used for food irradiation, archaeological dating, and smoke detectors and radioactive tracer. So the technology nowadays, you cannot easily identify this one because the radioisotope have a lot of application sa in the food industry, food irradiation. No, actually, one way of preserving food is through radiation in the form of as what we call this one archaeological dating. So, for example, carbon dating. So, that's another example for isotope, smoke detector, and radioactive tracer. Ang smoke detector is usually used by the American people in their nationality for any form of accident violation in the car. For what we call those one, they have a smoke detector in their car. Okay, so I think I forgot to tell you that that is my presentation is all about. And I think, yes, thank you so much. I don't have something to say, but of course, mm, please try to understand with this one, especially in determining the number of atoms, neutrons, and protons, and that will could be done on the next time around or the next meeting. But one thing for sure that this we will have a long quiz with this slide in the future. Just prepare with yourself because you will be given a different form of question rather, or most especially. I hope so. Okay. So what is happening to my PowerPoint? I'm just scanning if when is my last slide. But since my curtain is being rearranged, well, of course, yes, this is it. I think that's only the last topic I have. So the rest is all, of course, that's how we will end our lecture. So yes, this is the formula and doing how to compute the electrons, protons, and neutrons. And in this case, yes, that's all only have in my topic, okay? So sorry jud guys ang tanan kay maura to siya gaduka-duka lagi ko katugon mo ko. Well, I forgot to tell to put a last slide for thank you very much for watching and listening. Please be updated because I am going to upload another video as a continuation for this video. It's all about formula writing, chemical bonding, and atomic mass calculation. Okay, so please be prepared and thank you for always supporting us and God bless us all and thank you. Bye bye.